Hello everyone, my name is Annie and our topic is about the quadratic equation, and there are four group members, and I will talk about the background and the hidden form of equation, and next one will talk about the conception explanation and how to solve the equation. The last two members were related to the real life examples. The first one is the name and the definition. The name quadratic comes from the chord meaning square because the variable gets squared, like the square x. And it is also called an equation of degree 2 because of the 2 on the x. This is the standard form of a quadratic equation looks like this. A multiplied the square 2 plus bx plus c equal to 0, and a cannot be the 0. X is a variable or unknown, we don't know it yet. And the next one is the hidden quadratic equations, and there are four columns. The first one is in disuse, and second is to movement, and third is in standard form. The fourth is the normal number of the A, B, and C. The first one can move or change to left hand side, and the next one is expand brackets and move 5 to left, and third one can expand brackets and move 3 to the left.
And then I will talk about how to solve the quadratic equation. The solution to the quadratic equation are there. It is equal to 0. There are usually two solutions, as shown in the graph. They are also called roots or sometimes 0. There are three ways to find the solutions. We can factor the quadratic, we can complete the square, or we can use the special quadratic formula. Just put in the value of A, B, and C, and then do the calculations. More about quadratic formula. The plus minus sign means there are two solutions. But sometimes we don't get two real answers, and the discriminant shows why. Do you see b squared minus 4ac in the formula above? It is called the discriminant because it can discriminate between the positive type of answer. When b squared minus 4ac is positive, we got two real solutions. When it is 0, we get just one real solution. When it is negative, we get two complex solutions.
I'm going to do a real-life example about balls, arrows, missiles, and stones. If you throw a ball or shoot an arrow, fire missiles, or throw a stone, it will go up into the air, showing down as it goes. Then come down again, and a quadratic equation tells you where it will be. For the example, a ball is thrown straight up from 3 meters above the ground with a velocity of 14 meters per second. When does it hit the ground? We solve it by assume t for time in second. And firstly, we list up all the figures we know. The height starts at 3 meters. We get 3. Secondly, that it travels upward at 14 meters per second, so we can get 14t. Based on the Newton gravity law, we can get a accelerate a equals 9.8 meters per second square. So we can write it into minus 5t squared. So we can get gravity pulls it down, changing its speed by about 5 meters per square. So we can get minus 5t squared. Secondly, we add them up. We can get h equals 3 plus 14 times t minus 5 times t squared. When the height equals to 0, ball hit the ground. So we can get 3 plus 14 times t minus 5 times t squared equal to 0. And we write the quadratic equation in standard form, so we can get minus 5 times t squared plus 14 times t plus 3 equals to 0. So we solve the equation. We can get two answers. T1 equal to negative 0.2 and T2 equals to 3. Based on the real life example, because there will be no negative figures, so the answer will be T equal to 3. So the ball hit the ground after 3 seconds.
Hello everyone, and let's have a look another example, new sports bike. And you have designed a new style of sports bicycle, and now you want to make lots of them and sell them for profit. First, your costs are going to be 100,000 for manufacturing setup costs, advertising, and something like this. And second, for if $110 to make each bike. And based on similar bikes, you can expect sales to follow this demand curve. Unit sales equal to 70,000 minus 200 times price. And for example, if you set the price at price 0, you would just give away 70,000 bikes, and at price $73,050, you would not sell any bikes at all. And so let's make some equations. And the unit sales equal to 70,000 minus 200 times price, and sales in dollars equal to this equation, and the cost like this, and profit is equal to sales minus cost. And now we solve this equation. We can get the price equal to 126 or $334. It is exactly halfway in between. So the best price is $230. We can get this linear graph, and when the price is set the price is $230, we can get we can maximize the price, and the price equal to the 2.18 million dollars. Okay, that's all. Thank you for listening.